Okay, good afternoon, everyone, and welcome to MIDRC Monthly Seminar Series. Today, Chris Meyer, PhD from the University of Chicago, will present a seminar titled Building AI-Ready Cohorts Using MIDRC. Chris is a data scientist with a background in evolutionary genetics. He is currently the Director of User Solutions and Scientific Support at the Center for Translational Data Science at the University of Chicago, where he has been instrumental in MIDRC's evolution. Gen 3 is an open source software platform for building data resources and analyzing scientific data that powers the MIDRC's data commons, which Chris will demo shortly. Before we start, I would like to remind that we have a Q&A session at the end, and please put any questions that you might have in the Q&A box at the bottom of your screen. With that, Chris, the floor is yours.
Thank you. Thanks, Berkman, and thank you to everyone on the call today for joining to learn more about MIDRC. I'm extremely honored to be a part of MIDRC, and I think it's an incredibly important tool and resource for making advances in medical imaging research. There's a few things I'd like you to pay special attention to during the presentation today, which I've pre-recorded, so I'll be playing a video here shortly. But during the video, I'd like everyone to first and foremost just take in how much quality data MIDRC has. And it's data that's both open access and it's been carefully curated by teams of medical imaging and data science experts. There's several subcommittees in MIDRC, if you're not familiar or part of any of those subcommittees, that discuss, debate, and make decisions about how to develop the data exploration app that I'll demo here in a moment, as well as the underlying data model, which powers the queries and has been specifically designed with AI research in mind. The second thing I'd like everyone to note is how MIDRC's open APIs enable the research community to access that incredible data resource in a way that I think is unprecedented. There's a lot of data resources out there, even in medical imaging, there are many, and some of them are good, and as we call them, fair resources. And then some other ones aren't so great, or don't provide the necessary curation to make the data, findable, accessible, interoperable, and reusable. But I'm proud to say that I think that MIDRC is one of those. It's a wonderful example of a fair data resource, and I'm excited to share that with you. And then finally, as more and more data imaging data resources come online, especially with the NIH's data sharing policy that recently was updated, requiring folks to share their publication data. I think it's very important that these data nodes, these data resources, have open APIs and expose their data to queries and provide data access via APIs or application programming interfaces, so that these data nodes can be integrated into federated data discovery platforms like data meshes and data fabrics. So during this presentation, you'll hear you're talking about MIDRC's open APIs. Again, API is application programming interface, and the main thing to note is that it's a tool that provides a mechanism for querying and accessing data programmatically. And it's open because the API, use of the API isn't limited just to MIDRC's own applications in the data portal or to specific groups of users. Instead, it's open to the public. There's no need for anyone to launch a web browser and use point and click tools behind a login in order to do cohort selection. and analysis when you have an open API. Instead, the general public can obtain credentials from MIDRC and then send requests to MIDRC APIs, which empowers researchers to build programmatic workflows. It empowers developers to create new data exploration and analysis apps. And it enables federated discovery platforms like data meshes and data fabrics, like the up-and-coming biomedical imaging hub, to seamlessly integrate data hosted by MIDRC, all without the data moving or changing ownership. So with those three things said, I'll go ahead now and share my screen and launch this video. Hi, my name is Chris Meyer, and I'm the Director of User Solutions and Scientific Support at the University of Chicago's Center for Translational Data Science. In this video, I'll demonstrate how to build an AI-ready cohort of imaging studies using the Medical Imaging Data Resource Center, or MIDRC, data commons. If you're unfamiliar with MIDRC, I encourage you to visit midrc.org to learn more about how we're achieving our mission of creating an AI-ready data commons to fuel machine learning research in the domain of medical imaging. MIDRC aims to create a data commons that adheres to the so-called FAIR principles, meaning that data are findable, accessible, interoperable, and reusable. One aspect of this effort is providing open APIs to make programmatic searches over MIDRC data possible. To demonstrate the power of MIDRC's open APIs for programmatic data search and access, first, I'll use MIDRC's Data Explorer, which is a graphical user interface for data exploration that's built into MIDRC's browser-based data portal. Then, I'll show you how to build the same cohort using the same search terms by sending programmatic requests to MIDRC's Search API, which accepts GraphQL-like queries and returns the requested data in standard formats. Let's begin by navigating to data.midrc.org in our web browser and logging into the data portal. You can authenticate in MIDRC using either your institutional credentials via InCommons or using your ORC ID. All data in MIDRC are open access, meaning anonymous users can query and browse data. However, we'll need to log in order to download data or generate an API key for programmatic data access. After logging in, navigate to the Data Explorer by clicking on the exploration icon in the top navigation bar or manually going to the URL data.midrc.org/explorer. Cohort selection is the process by which we divide the data into groups based on shared characteristics. In the Explorer graphical user interface, we do this via the faceted search technique, where filters organized into tabs are used to narrow down our search results. MIDRC strongly recommends applying filters to narrow search results before attempting to create and use a file download manifest. Each tab at the top of the Explorer app represents a type of data one can explore in MIDRC: patients, image annotations, measurements, imaging studies, and data files. The main table of the Data Explorer represents records in each of these data categories depending on which tab you're on. So if you're on the Cases tab, each row in the table represents a patient. If you're on the Imaging Studies tab, each row is an imaging study, and on the Data Files tab, each row represents a single data file, and so on. The data in the table can be filtered down to those a researcher is interested in by using the filters on the left-hand side of the page. You can see that these filters are also organized into tabs representing different aspects of the data being explored. For example, on the Cases tab, one can use clinical data like demographics, medications, procedures, and measurements to filter the table of patients, and one can also apply filters related to patients' imaging studies, like study modality or body part examined. If, for example, study modality CT is selected on the Cases tab, the table of patients will be filtered to display only patients that have at least one CT scan in MIDRC. And if chest is chosen for body part examined, it will further filter the table of cases to those that have a chest CT scan in MIDRC. For this demonstration, we'll focus on the Imaging Studies tab of the MIDRC Data Explorer and use the available filters to narrow down the roughly 165,000 imaging studies currently stored in MIDRC to a subset of studies that meet our criteria. First, we'll use some patient clinical and demographic properties to filter the table of imaging studies to those of patients matching our selection. On the Case Demographics Filters tab, we'll select only imaging studies from patients that have had a positive COVID-19 test result by selecting Yes for the COVID-19 positive property. This property is a Boolean that indicates whether a case has ever tested positive for COVID-19. Then, for demonstration purposes, we'll select all patients aged 70 or greater by adjusting the age at index range selector. We'll then select male for patient sex, and finally select Hispanic or Latino for patient ethnicity. Next, we'll further narrow down our selected imaging studies by applying some filters based on imaging study parameters, which can be found on the Study Properties Filters tab. On the Study Properties Filters tab, we'll select CR and DX for the study modality property to filter down the table of imaging studies to those that include X-rays. Then we'll select a range of -2 to 0 for the imaging study property days from study to positive COVID-19 test, which is a property derived from the original data by calculating the difference in days between the date of each imaging study for a patient and the date of each of their positive COVID-19 test results. The range -2 to 0 means that patients should have received a positive COVID test result up to 2 days before their imaging study. Next, let's take a look at the LOINC Properties Filters tab. The LOINC Playbook is a medical imaging standard developed by the Reagan Street Institute and the Radiological Society of North America. The MIDRC Data Quality and Harmonization Subcommittee has used the LOINC standard to harmonize 1,475 disparate imaging study descriptions to a core set of 75 LOINC codes, each of which encompasses a harmonized study description, study modality, contrast indicator, and body part examined. Here let's select chest for the property LOINC system, which is the body part examined during the imaging study that's been harmonized using the LOINC standard. From here, let's navigate to the Annotations Filters tab. Here we'll try to further filter our chest X-ray imaging studies down to those that exhibit severe COVID-19 symptoms by selecting a range for the MRAIL score of greater than or equal to 20. The MRAIL score, which stands for Modified Radiographic Assessment of Lung Edema Score, is an annotation applied to imaging studies in MIDRC that attempts to quantify the extent and density of alveolar opacities on chest radiographs, which is an indicator of acute respiratory distress often seen in the lungs of patients suffering from severe COVID-19 symptoms. Now that we've applied several restrictive filters, the table of imaging studies has been filtered down to only 9 out of roughly 165,000. We can now download the filtered table of imaging studies in several different formats using the Download Table button. And if we want to access the image files themselves, we can obtain a file download manifest by clicking the button labeled Download File Manifest for Imaging Studies. The file download manifest contains a list of files that can be accessed via their unique identifiers, also called object IDs, or alternatively, they're called data GUIDs, which stands for Globally Unique Identifiers. Files can be downloaded either using the Gen3 SDK, which we'll look at here in a moment in the Jupyter Notebook, or using the Gen3 Client command line tool. To download the files in our manifest, we'll point the Gen3 Client Download Multiple command at our manifest, and the files begin downloading to the location we specify for the download path argument. For more details on how to download, configure, and use the Gen3 Client, please refer to the MIDRC Quick Start Guide that is available to download as a PDF from the MIDRC Data Portal header in your browser at data.midrc.org. Notably, on the Imaging Studies tab of the Data Explorer, one can also preview images using the integrated OHIF DICOM viewer by selecting Browse in DICOM Viewer in the table of imaging studies. In the DICOM viewer, all imaging series and annotations for the selected imaging study can be viewed, inspected, and measured using the OHIF viewer's tools. So now that we've walked through building a cohort and then downloading the structured data and image files associated with that cohort in MIDRC's Data Explorer interface, I'd like to pivot to a Jupyter Notebook tutorial that demonstrates doing the same programmatically with Python code, all by sending requests to MIDRC's open APIs. My aim is to demonstrate what I view as one of MIDRC's greatest strengths, which is that queries of the data are not limited to what you can do in the browser-based Explorer app. Through combinations of various posts to MIDRC's query APIs and subsequent post-processing using a programming language, like Python, complex and reproducible cohort selection and analysis is possible. MIDRC Open APIs can also be used by third-party researchers to create their own data exploration and analysis applications that run over MIDRC using its query and authentication APIs. And MIDRC's metadata APIs can be used to integrate MIDRC and other FAIR data resources into federated data discovery meshes or fabrics, like the Biomedical Imaging Hub. If you'd like to learn more about MIDRC APIs and how to send queries and access data programmatically, please navigate to the example analysis page using the icon in the top navigation bar of the MIDRC data portal. From here, you can access the MIDRC tutorial notebooks by following the link on that page to a GitHub repository where you can download the notebooks and try them out for yourself. The notebook I'll be walking through now is one I first presented at the RSNA 2023 conference's Deep Learning Lab in a session titled MIDRC, Building and Using AI-ready Datasets from a Massive Open Data Commons. In case you'd like to follow along, it is available in GitHub by the name MIDRC Cohort Building DLL RSNA 2023.ipynb. And it should run just fine in Google Colab if you're having any trouble running it locally. First, before running the notebook, you'll want to download an API key from the MIDRC data portal. Your API key contains the necessary credentials you'll need to send along with your API requests in order to authenticate. In order to obtain an API key, navigate to the profile page by clicking on the user icon in the upper right corner of the MIDRC data portal website after logging in. Click on the Create API Key button and download the file locally, somewhere safe. Note that you should never share your API key with anyone or post its contents in any email, messaging app, or online forum, since it's akin to your personal password to MIDRC, and it could be used to impersonate you if leaked. Now that you have an API key, launch the Jupyter Notebook locally or in a workspace like Google Colab, and point the variable cred to the location of your API key file. The next few cells in this notebook import necessary Python packages and initialize the Gen3 Python SDK classes we'll use for authenticating and querying data via MIDRC APIs. Gen3 is the name of the open source software platform developed by the Center for Translational Data Science at the University of Chicago that can be used to create data resources like data commons, workspaces, meshes, and hubs. And the Gen3 Python SDK is a collection of Python wrapper functions that make it easy to send common requests to the APIs of MIDRC and other Gen3-based data resources. In section 2 of this notebook, I provide some helpful links to more detailed documentation on how to build and send queries to MIDRC APIs. Feel free to browse this information at your convenience. For now, we'll skip ahead to setting parameters in our example query that will build the same cohort of imaging studies we previously selected in the Data Exploration app. In order to programmatically replicate the cohort we built in the Data Exploration app, we'll set an MRAIL score threshold of 20, minimum and maximum days from study to positive COVID test of -2 and 0 respectively, study modalities of CR and DX, body part examined as chest, and the patient demographic properties we selected earlier, Hispanic or Latino males aged 70 or greater. We then use these parameters to send a request to MIDRC's query API using the Gen3 query SDK class function raw data download, which can be used to download all the structured data for a particular data type. In this case, we're querying the data type imaging study, setting fields to none, which will return all fields, and using the field filter object to list all of our filter parameters with their corresponding operators. Since we want all filters to apply simultaneously, we'll group them under an AND operator. Then, if a specific value is used for a parameter, we'll use an equal sign operator for that key value pair, like we see here for link system, sex, and ethnicity. If the acceptable values are a list, as it is for study modality, we can use the N operator to select studies that have a study modality in our list of study modalities. Finally, for ranges like age at index, MRAIL score, or days from study to positive COVID test, we can use combinations of greater than, less than, and or equal to. For a list of all operators and details on how to format queries, see the links to documentation provided in this notebook. For a list of all terms and their definitions for all administrative, clinical, and imaging data elements MIDRC exposes to queries, please visit the MIDRC Data Dictionary Viewer, which can be accessed using the Dictionary button in the top navigation bar of the data portal. The data dictionary can be viewed as a table or a graph that displays the relationships between nodes. The MIDRC data model incorporates terminology from multiple standards and ontologies in order to harmonize and represent the relationships between different data types, including clinical, administrative, and imaging standard ontologies like OMOP, NCIT, the LINC playbook, and the DICOM standard. MIDRC subcommittees have carefully chosen terms from these various ontologies in order to create a simplified query schema for exploring the complex relationships between the clinical, imaging, and other data types MIDRC hosts. Investigators can use queries to create novel cohorts for their research and then access the original raw data files for those cohorts. All MIDRC data files have been thoroughly de-identified, but
but otherwise the original DICOM metadata is intact and available for researchers who desire to dig deeper into the details of a particular imaging modality or technique for their selected cohort. After running our query, we can see that the API response contains the same 9 imaging studies we selected in the previous demo of the Data Explorer. This is because the Data Explorer uses the same query API to retrieve the data it displays in its graphical user interface. The query response is in JSON format, which can be easily converted to a data frame using the Pandas Python package. If you list the data frame columns, you can see all 35 data elements related to the imaging studies, one of which is Object ID, which contains the image file identifiers or GUIDs for the imaging studies that can be used to download the corresponding file objects from cloud storage. In the spirit of giving another query example, we'll further drill down to image files of specific types by using another query based on the results of this first query. In this example, we'll query the data type data file, which instead of returning records of imaging studies, will return records of individual data files. In order to return only data file records related to the imaging studies we identified in the first query, we can make a list of imaging study submitter IDs and use that later in a query argument to the data file table. Different types of data files, for example annotation files and image files of different modalities, have different values for the source node property. In this example, we'll select only the CR and DX image files and thus leave out any annotation or other supplementary file types. When we build our data file query, we apply 2 filters. Our first filter specifies that the study UID of the files returned should be in our list of study UIDs derived from our first query. The other filter specifies that the source node of the data files should be either CR series file or DX series file, which will exclude any other types of files, including annotations or supplementary files. After running our query, 10 data file records are returned, and the files can easily be accessed using their Object ID field. In the next section, I demonstrate how to access the file objects via their object IDs using the Gen3 SDK DRS pull command. DRS, or DRS, stands for Data Repository Service and is a GA4GH initiative to provide an API that data consumers can use to access data objects in a standard way, regardless of where the files are stored and how they're managed. Here we'll write a simple loop to download each file using its object ID with the DRS pull object command. Once our loop is finished and we have all the images related to our cohort, we can preview them and inspect the DICOM headers using the PyDICOM Python package to make sure they're the files we intended to access. Thanks for watching this demonstration of how to do cohort building in the MIDRC Data Commons using both the graphical user interface on the Data Portal website and using API requests sent using the Python programming language. If you'd like to jump into using the MIDRC Data Commons but don't know where to start, check out the Quick Start Guide on the Data Portal homepage at data.midrc.org. If you need more specific guidance, please email the MIDRC Help Desk at midrc-support@datacommons.io, or you can email me directly at cgmeyer@uchicago.edu. And finally, if you'd like to learn more about MIDRC as a whole, please visit midrc.org or midrc.org. Thanks for listening, and happy data wrangling.
Okay, thank you very much, Chris, for that wonderful presentation. And we have some questions in the Q&A box. Some of them partially answered, I guess, but I would still like you to maybe respond to the first question in a more general way by Olasubami Omoleye about the links to the video and the notebooks shown.
Yeah, thanks, Berkman. Yeah, absolutely. I will share. Yeah, the video is brand new for this seminar. I will figure out the best place for it to live. I imagine it will get uploaded to YouTube and maybe also one of the MIDRC sites. I'm not sure if it'll be the data portal or if it'll be midrc.org or where it will end up, but I will make sure it gets disseminated once that video is uploaded. And I can share a link to the notebook. Yeah, looks like someone already posted it there. I don't know if folks still need that or not.
Yeah, and I do believe there are multiple notebooks under the MIDRC GitHub site. So not only this one, but I think other training uh, examples as well. So I think it would be great for folks to have a look there.
Yeah, and just a word on that in general. That page, it's populated right now with some notebooks that University of Chicago developed, some of our data scientists and myself. But it's really meant to be a community space. So if other folks from MIDRC would like to contribute their own notebooks, we're very much open to that and welcome that. So if you would like to contribute, we do have a help desk, which is linked on data.midrc.org. So that's the easiest way to contact me and my team, so we can incorporate your notebooks or any other questions or comments you might have.
Great, thank you, Chris. And we have a question from Flavius Nukubli. Do you have training opportunity for researchers from underserved populations with limited experience who are willing to learn more about this?
So I'm not sure myself if MIDRC has training workshops, but I certainly would be open to teaching one if the MIDRC leadership would like to do that. I'm an employee of University of Chicago, and we contribute to MIDRC. But I don't think that that's something that I could do myself. But yeah, if there's buy-in from MIDRC leadership, I think having a hands-on workshop is definitely something that I would be willing to contribute to.
Great. So maybe this is something we can bring up with MIDRC leadership. Great. Thank you. There is one question from Elena Badillo Goitechea. I'm sorry for butchering the name. Does the de-identification include the country and state?
Let me see. I'll need to. I'm not a de-identification expert. I believe we follow the HIPAA guidelines, which has a geographical component to it. I think we are allowed to give countries and states, but we are not allowed to go more granular than that. I think cities and zip codes are not allowed. We do have zip code as a code, like an encoded sort of de-identified zip code as a property in the data model, but we can't give specific locations. Okay, I see. Yeah, I've been told it's the first 3 digits of the zip code.
Yes, thank you. And there's another question by Mukund Seshadri. I recognize that MIDRC has already been involved in several collaborative projects with RSNA and AAPM. Is there an opportunity for individual researchers or groups to work collaboratively with MIDRC on research projects?
Yeah, again, this is more of a question for MIDRC leadership, but I think the answer is yes. Yeah, I know I guess your question mentions research. So I do know that RSNA hosts grand challenges using MIDRC data. So that's one opportunity. If you'd like to join a grand challenge, I think grand challenge number 3 is coming up here pretty shortly. And yeah, there's definitely research opportunities. I'm not really the authority on that aspect of MIDRC, but yeah, I encourage you to reach out using the MIDRC website to ask questions if you'd like to get involved. And I do think again, this is more a question for leadership as well, but I do believe we are working towards letting individual contributors contribute published data to MIDRC as well.
Great, thank you. And there's a comment that I would like to read on the Q&A session, just for everybody's information, that MIDRC is happy to host workshops as needed or answer specific questions from the users. The notebooks on data.midrc.org should be comprehensive for MIDRC beginners too. Please reach out to us, MIDRC Gen 3 team, by emailing midrc-support at datacommons.io by Ao Liu. And thank you very much for that comment and information. While others are typing maybe their questions, I wanted to ask you something about the how to format the correct query for the API, how to really have the correct naming for filter parameters, and maybe if there are acceptable values, how do we know what the acceptable values of those filter parameters are to correctly formulate a query? I think you showed on your presentation actually, but I think it went really fast.
Yeah, absolutely. If it's helpful, I can share again. And got the notebook pulled up here. And yeah, if you go to the notebook itself, I did try to add a lot of those links into the notebook itself. So the Gen 3 SDK is a general SDK written in Python for interacting with various Gen 3 resources, including MIDRC, but also includes many other projects that are using Gen 3 as its the platform, the basis of the platform. And yeah, these links will link out to GitHub. So this is in our query service, which all of our software services have fanciful names. This one is named Guppy. This is the query service. And yeah, there's a lot of documentation here. And obviously we don't have time to go through all of it, but it goes through the syntax, it goes through different types of queries like aggregations, creating your filters. I think is not super easy. So I understand why folks would need documentation. And that's one of the main reasons why we have, again, to show you, this is the MIDRC data portal, data.midrc.org. And to just show you really quickly, again, since the video went quickly, there's the quick start guide here, get started at the top. If you click that, it'll open up this PDF with how to get your API key, how to download the data access tool and configure it. And then if you use the example analysis button here, it'll take you to those tutorial notebooks with a link to the GitHub repository where you can download the actual notebooks. So that's one of the reasons we have these notebooks, is just to show folks. Here's another one with lots of documentation. You can see I wrote this one last year, but it's got just a lot of different methods and some examples. That's the thing I really like about notebooks over documentation is you can literally run a working example and you can fool around with changing some of the parameters and see how it changes the results. So there's notebooks, but there is one more place besides the documentation in the notebooks that I want to point out, which is, let me just log in really quickly. And this is a little bit hidden. So you're getting some insights here. But if you go to, if you type in query, it'll take you to a query builder. And this is probably a little bit more for the advanced users if you're comfortable, with programming and sending queries and writing queries, that sort of thing. If you click Docs over here, it will expand with some specific query documentation that gives you the GraphQL schema for sending queries. And you can see, so in the two examples I gave in the video, we queried the imaging study index and also the data file index. So if you were interested to see just a comprehensive list of everything you could query for imaging studies, you can click through this documentation. There's some aggregations, like you could count the number of CTs in an imaging study. And then there's all of these parameters that you can be used in queries. So anything that's listed here, this is the parameter you would use. And then over here, you can start typing in the query builder, and it features autocomplete. So that's really handy for learning how to query. So you can see all the options here. If you wanted the first 1,000 imaging studies and their object IDs, for example, you can do that, and you can mess around here with filters as well. Again, that's at the query endpoint of the data portal, data.midrc.org/query, if you'd like to access this query builder.
Yeah, wonderful. That's very useful, Chris. Thanks a lot. And again, the name of the filter parameters, they are also under the dictionary tab, I believe, right? So if you go to click on dictionary and then go to like image series, then it will also show or imaging study, it will show all those parameters that you used in your query.
That's
Thank
right.
you.
Yeah, and that's a good point, Berkman. Yeah, and it also will give you the definitions of those parameters if there's any ambiguity as to what they mean. We try to be very clear about what the different parameters actually mean.
Thank you. Now there are other questions in the Q&A box, so I'll go back to that. So another question from Olasubami Omoleye. Are there limits to how many times a single user can download a cohort selection?
There are not. We do encourage, like I mentioned in the video, we encourage folks to be mindful of the bandwidth they're taking. So don't try to download the entirety of MIDRC several times because there are data egress charges that the MIDRC funds will eat. So do be mindful of that. But no, there aren't currently any limitations that I'm aware of on how many or which cohorts you can download.
Thank you, Chris. Question from Justin Kirby. Do you happen to know if Gen 3, the tech that appears to be powering MIDRC, only supports radiology and clinical data, or can it also handle digital pathology images?
Yeah, so Gen 3 is completely agnostic to the type of data you're trying to host. You can create your own data dictionary. We have several that you can borrow from if you don't want to start from scratch, including genomics and imaging and clinical data. And let me share really quickly one more time to show you stats.gen3.org, which is sort of a list that we like to show off from time to time of the different data meshes and data commons that we host here at the University of Chicago. There are many others that are Gen 3 is open source, so you can go to GitHub and download it and use it on your own without telling us. and there are some groups doing that, creating their own data commons with Gen3, but these are some of the ones that we manage. And you can see that they have a variety. There's an environmental data commons with environmental weather station type data. There's MIDRC, and there's the veterans oncology, which focuses on cancer. Blood Pack here is one of the first ones. It was a cancer moonshot project from 2016. This one focuses on blood biopsy in cancer. Justice Opioid Innovation Network, or JCoin, focuses on the opioid crisis, and that a lot of that is clinical type data. So yeah, there's a wide variety of different data types that Gen3 can handle.
Thank you. And I'm guessing that with the similar structure for API queries, you can query all of these other data sets as well. So I think this is useful not only for MIDRC, this exercise, but other queries or other data sets from Gen3 as well.
Yeah, correct.
Okay, we have a question from Elena Badillo. What other health outcomes are available other than COVID-19 positive, negative, thinking about, say, predictive modeling purposes?
Yeah, so we've started to ingest, besides just the raw clinical and imaging data, we've started to ingest image annotations. A lot of those are expert curated, and some of them are AI or machine learning generated. And we have indicators. We're adding indicators to the Explorer and the data dictionary to indicate, where these annotations come from, whether it's a computer or a person. But that's an ever expanding list of labels on MIDRC's raw data. We also, like I mentioned, we have clinical data. So this is EHR data, which includes, for the patients that we have clinical data for, includes conditions and comorbidities, like diabetes, hypertension, et cetera. And I believe we're also getting long COVID data sets at this point, which are coming soon. They're not labeled as such in the data portal yet, but I think next month will be our first potentially batch next month of long COVID. And I also have heard that we are planning very soon to start hosting cancer-related data. So there will be other disease types besides COVID-19 in the near future, but at least currently, COVID-19 has been the main focus of MIDRC.
Yeah, that's very very good to know. And yeah, I can't wait till those other data sets are also included in the MIDRC Commons. So I don't see any other questions in the Q&A box, and we are almost at time. So I would like to thank you again, Chris, for the wonderful presentation, and would like to thank everyone for attending.